Okay, today we're talking about 6.1 antiderivatives. We're not going to talk about the slope fields part of it yet. That'll be for later. But an antiderivative is functionally an integral. The rule on integration is I'm reversing the derivative. So I can think about what has a derivative of, what has a derivative of 2x? Well, that would be x squared. But it's also x squared plus 2. So this dx part is essential for taking the antiderivative or the integral with respect to x. So if I'm looking at derivatives, though, equals 2x. Oops, I should have parentheses around that. The derivative of x squared minus 17 also has a derivative of 2x. So there are x squared plus any constant is going to have a derivative of 2x. So when I do an integral, this is called an indefinite integral. We'll talk about what definite is in a second. We have to add this plus c. At some point we will solve sometimes we will solve for c, figure out what that constant is, but we need some additional information to be able to do that. If not, we just put it as plus c. One of the other examples they give in the book for this was example 3, actually. X squared minus pi still has a derivative of 2x. So c can be any real number. Okay. So what am I doing? The general rule for an integral is add 1 to the exponent, divide by the new exponent. And yes, you can do this term by term with addition, just like we could take derivatives term by term. Okay. So this is x to the 6th over 6 plus c. First thing I'm going to do is change this to a fractional and negative exponent. So now I can apply my rule. Add 1 to the exponent, that becomes positive 1/2 over 1/2, which when I simplify that is 2 square root of x. Dividing by half is multiplying by 2, so that's where I get the 2. X to the 1/2 is square root of x. E to the x is just e to the x. But the chain rule would say I would multiply by -3, so to reverse the chain rule, I must divide by -3. So this -3 here, instead of multiplying by the derivative of the inside, I must divide by it. Okay. Do another one here, different color. What has a derivative of cosine? That would be sine. Keep the inside the same. But normally I'd multiply by 1/2, so I'm dividing by half, which is multiplying by 2. And as always, put your plus c. And final one. X squared, I raise the power by 1 and divide by that new power. Negative 2x, I raise the power by 1, divide by 2, so those will end up canceling. And then always plus c. So final answer for this, I'm just doing it term by term. Okay. And that lets me work it out. Actually in the book, I'm going to show you what they show in the book. And I'll tell you why. So they're going to integrate each part separately, which you can do. It's functionally what I did. So I get x cubed over 3 plus its own c. So C1, C2, C3 are all constants. When I add constants together, they could be positive, negative. Doesn't matter. C could be a negative number, where I'm just adding these constants all together to get my C. So I don't need, oops, not plus C, equals C. I do not need I do not need 3 different C's. Okay. That is where we're going with integration today. We'll get more advanced next week. We'll talk about a little bit more advanced. Yes, we reversed the chain rule on this, but my chains were just numbers. We'll talk about how to reverse the chain rule with things that are more derivatives that are more than just a constant next week. We might briefly discuss how to reverse the product rule, but I'm not sure if that's in the curriculum or not. I have to look really closely because I haven't seen it yet. Okay, that is taking antiderivatives.